waiting room, so went ahead and opened up here a couple minutes early. Thank you all for joining. I am Chris Catterton with OneTech. We will let a few minutes pass here, let the rest of the invitees join, and we will get started momentarily. Thank you again for joining. All right. I know we're at the top of the hour here, still having some people trickle in. We'll get started here in about 60 seconds or so.
All right. So it looks like mostly everyone has joined, and the last of them are trickling in now. So I will go ahead and kick us off. Thank you again to everybody for joining us for today's session. My name is Michael Robledo, and I am your host. And I'd like to just go ahead and open up the chat right now. If any questions arise, feel free to put them in at any time, and we'll be sure to address them at the end of this presentation during our live Q&A session. So as a brief overview of today's agenda, we'll start off with a quick introduction of myself and Chris here as your presenters, and we'll dive right into it with some industry trends that are driving transformation across multiple industries. And then we'll take a look at how OneTech is defining the endpoint and some of the key benefits that lead into why you should consider the endpoint. And then we'll take a look at really what it looks like to have AI on that endpoint, and the business value that is driven from deploying endpoint AI across your operations. And we'll close out with a use case around predictive maintenance, and introduce our upcoming webinar covering embedding AI on MCUs. And then we'll open it up for a live Q&A session. So as a brief introduction, again, my name is Michael Robledo. I'm a digital marketer here at OneTech. I spearhead our webinar series and virtual events initiatives, as well as head up our partner ecosystem. And I'm joined today by Chris Catterton.
Yeah, hello everyone. Thank you for joining. My name is Chris Catterton, Director of Solution Engineering here at OneTech. I and my team get involved very early on in conversations with our clients and our partners, and take those discovery conversations all the way through to deployment. So thank you again for joining. As Michael mentioned, feel free to drop any questions that you have into the chat, and certainly look forward to this educational
Excellent.
session.
Thank you, Chris. So to dive
Thank
right
you,
into
Michael.
it, we're going to
So
take a look
would
at
like
some of
to
the
start just
most
by
transformative industry trends that are happening right now. And as many of you know, with the current state of the world we're living in, there has been a rapid acceleration in transformation and the adoption of emerging technologies across industries to adapt to operating in the new normal as we continue to understand what that could potentially look like. So, really starting out, arguably two of the most impactful trends currently are industrial IoT and Industry 4.0. From enabling predictive maintenance and analytics capabilities to delivering improved worker safety and product quality, as well as delivering real-time insight into asset performance and health across IoT environments, and of course the evangelization of smart factories. Industrial IoT is really propelling enterprises into a new era of operations. And when you look at the impact of Industry 4.0, we're seeing, a rapidly growing number of connected machines and devices that are generating vast amounts of data every second. And this is really highlighting a critical need for enhanced IoT security due to more of these data sources becoming susceptible to malicious cyber threats like the infamous zero-day attack, as well as ransomware attacks. And so with all of that in mind, looking at how OEMs are adapting, they've started to embed AI on hardware as a value add that deliver off-the-shelf end-to-end solutions to end users, such as predictive maintenance enabled equipment. And the focus really has started to shift to delivering these solution-oriented products that help combat challenges around the digital divide, which is made up of key pain points around security gaps, whether that's technological or human error, legacy equipment, lack of IoT-ready infrastructure, and that constant pull between data latency versus data privacy. And as the market becomes more and more flooded with emerging solutions to these challenges, it can be really difficult to identify those most cost-effective solutions that are going to deliver a true ROI. And so now that we've kind of gotten a lay of the land on what these transformation trends look like, I'm going to hand it off to Chris, who's going to dive into how OneTech goes about defining the endpoint.
separating out endpoint and edge. There's a lot of buzz around edge AI, as I'm sure most everyone here is aware of. But the edge is rather ambiguous. Is it an IoT gateway? Is it a communication hub? Is it a server that's just sitting on premise? I guess it could really be any of those, right? So here at OneTech, we really separate and differentiate ourselves to the point of being able to train our machine learning models directly on this endpoint. And we'll dive into that at a much deeper level here during this discussion. But just to kind of set the stage of, what exactly is the endpoint, and our definition here is it's where the data originates from, right? So think of the billions and billions of assets that are deployed, all powered by microcontroller units. They are generating a lot of data, and that data is not being fully utilized. So by being able to live and specifically train our model on these endpoints has a very long list of business values that come with this. So we're capturing data directly there at the source. In traditional methods of AI deployments, you would typically pull a lot of historical data from these endpoints, pull that data up into a cloud environment, process that data, train your model in that cloud, and have a standard model pushed out to each one of these endpoints. So not only does this process take quite a bit of time, but there's a lot of legwork involved in actually capturing that data, pulling it together, transmitting that up into a cloud, storing it in a cloud environment, and finally processing to form that trained model. So, of course, there's lots of cost associated with that typical method. Not only is it costly to just use resources to pull that historical data together, but then you have to transmit the data. So let's say you're using cellular protocols to get that up into a cloud. Obviously, that would be costly. And then furthermore, you have your costs associated with the cloud environment, so storing and processing. On top of that, your model that's formed inside a cloud, you would have a same model that's pushed to each individual asset, and these assets may be in different physical environments, right? You may have some that are in North Dakota here in the United States, and then you may have some that are in Central America. The environmental pressures on these assets would cause them to behave slightly differently. So that standard model and typical approach that a lot of AI organizations are using by training one standard model, pushing down to the endpoints, we don't believe is the most accurate or best approach for this type of solution. So to that point, here at OneTech, we heavily focus on endpoint AI, training our models directly there at the source. That way you understand the exact environment that it's in, the processes that it's going through, what a normal cycle looks like for these assets. Furthermore, there's very little latency between capturing that data directly there at the source, processing it, producing that outcome from the AI engine, and taking action upon that. So the action could just be a simple alert that goes to the stakeholders that are associated with an asset. It could trigger an automated response where you are causing that asset to perform differently. If it's an IT asset that you're communicating with, maybe you want to cut network traffic, or maybe reset or reboot that device or asset. So we'll dive into that in a use case here momentarily. Last couple of points here, there's really a convergence of OT and IT data, right? So not only are the solutions that we're deploying capturing sensor level data, but we're also capturing some of that OT level data where we're pulling in PLC tags and MES system data of how these assets are actually performing inside their environment. So all of that being said, with our approach to endpoint AI and why we believe it is a must in these types of deployments is, we're shortening that payback period for an IoT deployment, and on top of that, certainly lowering cost by alleviating the costs that come with a needing to form inside of a cloud environment and transmit that data to a cloud. So moving on, let's take a little deeper dive on how we accomplish this. So AI at the endpoint. First, you would fuse your various inputs. So whether it's accelerometer data, it could be temperature sensors, whether it's a surface-mounted temperature sensor or a temperature bearing probe. It could be gyroscopic or current and voltage readings that are coming out. We work a lot with acoustic emission sensors. Think of small microphones that are listening to frequencies of core components on these industrial assets. Overall, we're agnostic to what these data inputs are. So the first step would be to fuse these data inputs into the MicroAI engine. So here in the blue box here, fuse that data, form that model, right? And I can't stress it enough. We're forming the model directly there on these very small footprint devices. So think of your, Cortex M4 MCU range, ESP32 type of MCUs. We're able to live on, something as small and low compute power as that family of devices. So we're forming the model, and depending on what a normal cycle is for the asset is what would dictate how long we train the model. A couple of examples. One, a robot may perform its task and complete a cycle every 7 seconds, right? So every 7 seconds, it's doing the same operation. So just by training over the course of a few minutes, we're able to understand what a normal pattern is for that machine. I think I've talked about this on previous webinars. An extreme other end of that would be a water pump that turns on for 7 minutes once a day to perform a backwash cycle. So in that instance, we would need to train over multiple days to understand and have the model learn that it's completely normal for this asset to sit dormant for 23 hours and 53 minutes. So all of that being said, the second step is training the model. Once you have that model trained, you would switch that over to a deployment production mode where you start running the inferences and produce those outputs. Now, where the outputs go is really up to the end user. So if they have existing IT systems that need to consume this, we can certainly push this information to those systems. So in the manufacturing setting, you'd probably want to have this tied to the manufacturing execution system, probably your maintenance system, along with your work order management and dispatch management if you're in the field service side of the house. Along with that, being able to send the outputs to data visualization tools. So whether it's a desktop app or a mobile app for reporting, you can start to further analyze the output. Is it a particular make or model that's causing the most issues within inside of your deployment? Is it a particular customer or region? So this is where those comparisons can be run inside of these data visualization and business intelligence tools. Furthermore, of course, are your workflow management tools that could consume this. So again, whether it's your support system or warranty management tools, your service scheduling, product cycle management, all of which can consume the output from MicroAI for really stitching together this end-to-end solution. All of that being said, I know I mentioned this earlier, kind of converging not only the sensor data, but existing intelligence within inside the ecosystem. So if there's IT systems or think of PLC tags, controller data, we can consume that through Modbus or OPC, pipe that into the model. Service logs or maintenance logs could also be piped into MicroAI to really create that comprehensive view of exactly what's happening with these assets. So just kind of expanding upon this slide a bit, again, we're capturing and processing there directly at the source. Part of the deployment of MicroAI, I know I've been speaking a lot on the industrial and predictive maintenance type use cases, but we can actually look internal to these IT connected assets and pick up possible endpoint threats that are occurring. And this is all done through our behavior analysis. I'll go into more of the security here in the next slide. Really to overview and get into the AI engine itself, it's a multi-dimensional behavior analysis algorithm that's running recursive analysis. And basically what this means is that each variable that's being fed into the AI engine is affecting the thresholds that the AI engine is determining is normal, right? So you'd have an upper and lower bound for each one of the inputs. And based on how each variable is moving, those thresholds may adjust in correlation to one another. And since it is behavior analysis, we don't need a lot of historical information to understand and form our model. We're able to observe, again, through that training phase of what a normal cycle looks like for this asset, and then switch it over to start running that inferencing. Last couple pieces here. Again, I mentioned we're agnostic to the sensor data, or really the data inputs. We're also agnostic to the communication protocol, right? So however we want to push the data out from the engine, agnostic to that. And then also where the data needs to go, agnostic to those systems as well. So let's look at really who benefits from this type of technology. So starting with the silicon and hardware manufacturers, we're working with a lot of people in this space where we are embedding this machine learning algorithm directly into the hardware architecture as a machine learning platform. And what this allows is for the customers of the silicon hardware manufacturers who are buying that board or that piece of hardware and embedding it into their equipment or into their devices. It allows for a differentiated offering, right? So MCUs are starting to become a little bit commoditized, right? So always looking for a way to differentiate inside the space. So by being able to embed this MicroAI machine learning platform into those boards and sell to their customers certainly has a lot of benefits associated with that. From there, those smart equipment or smart device manufacturers are able to take the MicroAI platform and then customize the solution for their specific use case. So let's say, as in the picture here, we have a robotic arm. It could be a robotic welder, robotic handler. Obviously, lots of robots being deployed in this Industry 4.0 phase that we're in. And through the data fusion level, they are able to select what the data inputs will be and do some feature engineering. We have tons of information in our knowledge center that allows those smart equipment and smart device manufacturers go in and start tuning the feature engineering specifically for their use case. Then, of course, they are then selling to the end users or the asset owners. So the asset owners would then reap the benefits of having, machines that are opening up work orders for themselves or devices that are alerting whenever they're not exactly performing to how they're planned to perform. Beyond that, though, of course, there are hundreds and millions of assets that are deployed, legacy equipment that doesn't have this level of intelligence. So what we're able to do is really go in over the top and place additional sensors or over-the-top sensors to stitch together the health and behavior of the core components of these assets. So certainly not restricted to working with just silicon and smart equipment that has this embedded today, but can also come in and work in this brownfield space where, the legacy equipment that does not have the intelligence come in, place sensors, place it over the top MCU or MPU, form the models, and then start sending out the AI output. And just to state it again, if there are any questions, feel free to drop it in the chat. See, a couple have been submitted so far. So let's switch over to talk about the business value of AI at the endpoint, and specifically in the security space. I know I've kind of been heavily focused on the industrial side of the house just because we have seen the value that's driven there and the ROI that's driven there. One more item to note on the industrial side, with the ability of training, processing, and running this model there locally, we're able to get very, very granular with our sampling rate. So we have deployments where we're pulling data every 50 milliseconds per sensor. And if you think of a single asset that may have 10 sensors on it, and across a single manufacturing floor, you may have 200 assets. Every single second, there are thousands of data points being generated. Now, if you had to process this in a cloud environment, it would almost be unattainable just due to the cost of transmitting and processing that inside of a cloud. So additional business value and benefit of living there and processing at the endpoint is getting very granular with that sampling rate. But let's switch over to the security side. So instead of looking at those physical sensor values, right, not necessarily looking at bearing temperature, motor temperature, cycle rates, but rather look internal to these IT assets. So let's think of CPU utilization or memory usage. We could also look at data packet size and frequency. As far as IoT devices go, they have a pretty common pattern of how they operate, right? So let's say I have an IoT device that wakes up at once an hour, sends an 8 KB packet, and then goes back to sleep, and then it repeats that cycle. And then all of a sudden, it may wake up and start sending a 64 KB packet once a minute, right? So obviously, this would be detected as an anomaly, and you could trigger action upon that. So whether it is cutting network traffic to that device that protects the network, you could reboot the device or reset the device whenever those are detected. So this is heavily focused really on that endpoint threat detection and specifically around the area of detecting zero-day attacks that are becoming oh so prevalent in our world today. So let's look at a real-world use case here, working with a large tier 1 automotive manufacturer in a few different facilities. This one in particular is an automotive body assembly line. So lots of MIG welding happening along this line. Each one of these robots has a specific weld placement that they're going through, and the particular line before we got involved was running at about 50% OEE, or overall equipment effectiveness. Industry standard is around 85%, so they certainly had some room for improvement here. This was primarily due to two reasons. One was unexpected downtime, and actually a lot of unexpected downtime. And secondly was with poor quality of weld. So our process was to understand, again, what intelligence exists inside their ecosystem today. So these robots actually had some embedded sensors that we were able to connect into. These were primarily on the gyroscopic side and energy usage, current and voltage from both the welder heads and the motors. There's 3 motors per robotic arm here. So we're able to pull that in, but we did not have, there were some gaps within inside of the overall health and performance of the asset. So we brought in additional sensors for these robots, looking at motor temperatures, right? And furthermore, with accelerometers and inclination sensors to start forming pathing for these robotic arms. And I know I'm going pretty deep here, so I'll leave it at that. From there, right, we were able to install those sensors, start forming what's normal and abnormal, and get to greater than 80% for this particular line. And again, this was due to being able to alert on when a robot was trending towards a sign of failure, right? So bearing temperatures, excessive vibration, an abnormal path for that robotic arm to travel, any of those types of trends, right? If we're trending towards that or observing it, then we were triggering action. So early days, we're sending out alerts and opening up work orders for corrective action to then take place. Furthermore, the next step is for the classified output. So whenever we know that a data signature is a particular type of issue, we're able to talk to that robotic controller and take that corrective action automatically. So one is on the unexpected downtime and predicting when it is trending towards that sign of failure and taking that proactive action prior to any issues or downtime occurring. The second reason for getting to this greater than 80% was due to whenever these robotic arms finish their cycle, they go back to what's called a pounce position. And it actually looks like the robot is about to pounce out. So it kind of sits back and whenever it starts its new cycle, it pounces forward. when it goes to that pounce position, if it did not go back to, let's say, a true north or a 0 degree, even if it was off by just a fraction of a percent, whenever it goes to make its next weld, the weld would be in the incorrect spot. And for this particular line, the QA, quality assurance, actually didn't take place until the end of the line. So if that that welding robot continued to place that weld in the incorrect spot, there were 15 additional vehicle bodies that had that incorrect weld, which then had to be taken off the line. Rework had to be done to fix those welds and then put back onto the line. So obviously there's a lot of negative business impact for having that occur. So we were able, through that pathing method, to determine exactly how that robot is sitting in that pounce position, that if it was not at that ideal kind of true north or 0 degree, we're able to trigger it to reset prior to going to make its next weld. And from here, I will pass it back to.
Absolutely. Thank you, Chris. So just before we jump into our live Q&A,
so it really
just
depends
wanted
on
to bring your guys' attention to the remainder of our sessions across the rest of 2020. So we have 3 more sessions throughout this series. The next one coming up in September, we will be taking a more technical dive into how OneTech goes about embedding AI in various MCU environments. And then following that session in October, we'll be taking a deeper look into really how IoT threat detection with Endpoint AI helps enterprises stop that 0-day countdown and really prevent those cyber threats from becoming catastrophic. And lastly, to close out the series with our session in December, we'll take a deeper look at how OneTech's MicroAI is delivering a true IT and OT convergence to help enterprises gain that competitive edge. And so with that, we'll now open up the floor for our live Q&A session. And Chris, it looks like we had a few come in throughout that presentation. The first question that was submitted is, what is the size of the footprint that our AI engine has on hardware?
Environment. For an MCU environment, on average, we're taking up about 170 KB of flash memory. For RAM, it's about 50 KB. And as far as CPU usage, we're right around that 1.5 to 2% mark for that utilizing the CPU. So not intrusive at all to these microcontroller environments.
Perfect. And another question was, what are the outputs from MicroAI?
Yeah, good question. Michael, if you can just mute on your side, getting a little bit of feedback. So so there's a handful of designated outputs from MicroAI. First would be your notifications and alerts, and these are actually 2 different outputs, and you can set the threshold for these notifications and alerts. Notification would be a little less severe. So let's say that the AI picks up that a specific data point is 1.5 or 2.5 standard deviations outside of what is considered the normal threshold, then you could trigger a notification. You could set the alert threshold to be, let's say, 3.5 or 4.5 standard deviations outside of that normal threshold. So first and second outputs would be the notifications and alerts. We also generate a health score for each one of the assets that we're connected to. And again, when I say asset, I'm using that term for both devices and physical machines and pieces of equipment. So by aggregating the various data points for these assets, we can look at its variation. So if everything's staying within normal bounds, your health score would be quite high. And right now the health score is from 0 to 100, 100 being perfectly healthy, probably brand new out of the box, or rather at least a broken machine that's well maintained. From there, if we start seeing a lot of variation in, let's say, cycle times or vibrations, temperatures, right, we would start degrading that health score based on that variation in the outputs. Fourth output here would be days to next maintenance. So there would be an OEM set kind of static threshold for how often you should service these assets. So let's say it's every 30 days or every 300 working hours you should perform a maintenance. So we actually set a predicted days to next maintenance. And the business value with this is if we determine that the machine is perfectly healthy, but you have it slated for bringing the line down to perform a maintenance, we may suggest that you push that maintenance out by a day or X number of working hours. That allows you to produce more units in the manufacturing setting at least, which obviously directly has a positive impact to that bottom line. And then last would be overall equipment life remaining. So based on looking at how often we're servicing, what the variation in data outputs are, we would start to estimate how long this machine will continue working without excessive maintenance, which would have an impact of not being value driving for the organization. So just to recap those, notifications and alerts, health score, days to next maintenance, and overall equipment life remaining.
Like we've covered the questions for this session. If there are no more additional questions, I would like to take this time to thank everyone again for joining us, and we look forward to our future sessions and having you guys join in.
Wonderful. Thank you all. Thanks, Michael.